Hey everyone, welcome to physics. We are going to use Coulomb's law equation to solve for force between two charged particles. So before I get started, I just want to take a look at this formula here. Force is going to be equal to K, which is a constant value listed over there on the right, which is 9 times 10 to the 9th newtons times meter squared over Coulomb squared. Q1 represents the first charge you're going to be given. Q2 represents the second charge you're going to be given. And distance is always squared. That's something that you really need to be concerned with. Sometimes students will multiply by 2. Squaring something and multiplying by 2 are not the same thing, so just be careful with that. Another helpful hint is to always make sure that you're using parentheses around your numbers and using your calculator's built-in exponent rather than typing times 10 with the caret and then the number. Utilize, there's like a little E button in your calculator that will be listed out in a future video. So I'm going to put a question mark by force since that's what I'm solving for here, but I'm going to read the question first. So calculate the force between a 0.006 Coulomb charge and a 0.001 Coulomb charge that are 4 meters apart. Okay, so I've got my question mark there by force. My K value, that's something you're never going to have to memorize. You're always going to, it'll be given to you on your quizzes and exams. So I'm going to write it in here. So it's 9 times 10 to the 9th newtons times meters squared over a Coulomb squared. My first charge, well, it doesn't really matter which charge you put first, but I like to just put the charge that I hit first. So I'm going to put 0.006 coulombs. The second charge is 0.001 coulombs. And then distance, they told me it's 4 meters apart, but remember, you have to square that distance. It's very important. So just so that I don't get tripped up later on, what I would do right away is just square that distance. Okay, so 4 squared is 16. So I'm not actually going to use this. I'm going to write 16 meters squared. And that'll just make my life easier later on, so I don't accidentally use that wrong number. Okay, well now let's plug things into our formula. So force equals, and here's where parentheses are going to kind of keep you organized. That K value goes first, 9 times 10 to the 9th. And then my Q1 charge is 0.006. My Q2 charge is 0.001. And that's all going to be divided by my distance squared, which was 16 meters squared. Okay. This might look a little bit messy. It might look a little overwhelming, but the easiest thing to do, don't plug this all on your calculator at the same time. Clean up that numerator first, get yourself down to one number, and then divide your numerator by your denominator. And you'll see that you're going to lose some units when you do that. So when you multiply 9 times 10 to the 9th times 0.006 times 0.001 in your calculator, you're going to get 54,000. So F equals 54,000. And if you notice, when you multiply these units together, they're going to cancel. And you're only going to be left with newtons and meters squared in your numerator. And then I'm going to pull my denominator down here. That's going to be much cleaner and much easier to divide in your calculator. And again, if you're keeping an eye on your units, you're going to see that the meters squared are going to cancel. So when you divide 54,000 divided by 16 in your calculator, you're going to get, let me cross these out, 3,375 newtons. And that makes sense because if you look, it's the only one that you're left with. And it's an easy way to make sure that you're on the right track because newtons are the unit for force.